and we can then spend some minutes. So roughly about 5-10 minutes should be good.
Yeah, I think that should be great. Um,
All
all
right,
right.
perfect. Keep it short.
It's spinning. So let's see. Hold on. It's not recording yet. There we go. Okay, the recording started. Go for it, Jim.
All right, cool. Thank you. All right, so I'll talk a little bit about the cosine integration we have so far, what our plans are to GA the current features, as well as some of the newer features we're, kind of looking at incorporating. So first off, just to kind of talk a little bit about why Kyverno and what differentiates it and where we're seeing, adoption versus, of course, other tools like OPA Gatekeeper, as well as, other policy controllers, motion controllers. So the whole focus or the idea behind Kyverno was to build a policy engine really, just focused on Kubernetes. So it's not a general purpose policy language. It's not intended to work outside of Kubernetes, but something that understands how Kubernetes works, is able to read things like OpenAPI v3 schemas from the API server, apply any other well-known sort of patterns, idioms like pods and pods controllers, work with all the other Kubernetes tooling nicely. And that was the idea behind bringing Kyverno out as a project. And we're seeing, quite a lot of, success with that. So we're obviously, at first we were a little bit hesitant to say, well, OPA Gatekeeper is already out there, it's established. Is there a need for a new way of doing policies? And I think the resounding answer we got back was yes. So that kind of motivated us to donate this to CNCF, and the adoption is just kind of, we're right now about over 1 million downloads per month and growing. So there's certainly a lot of interest and use already in the project. One other key thing in Kyverno, which is different than other policy engines, is our focus was not just security, which of course is a very key area and very strategic, but also automation, right? So it's like reducing the friction or reducing the handoff between different roles that are involved in a Kubernetes cluster, like your dev, sec, and ops, of course. That was very important, and making sure that we're able to generate based on different triggers. So Kyverno helps quite a lot, and in fact, that we see that either it's security or automation as the first use case, and then that expands into other use cases. And another important thing was to have a comprehensive kind of sort of approach where it's not just about admission controls, but it's in your CI/CD pipelines, runtime and background scanning. So all of this is first class in Kyverno, right? So it was designed for that from the beginning. So diving into what a policy looks like, and then we'll talk more about the cosine integration. So Kyverno policies are just CRDs, and they have match and exclude blocks. And as you can imagine, those will either select like resources, labels, namespaces. Kyverno also auto-populates things like roles, so more enrichment of data from the API server. And then once you match and exclude based on what so there's variables and data, like for example, if you have an incoming set of resources, Kyverno will automatically populate variables for images, things like that. So just make it easier to write policies and rules, right? And then after you match and exclude a policy, this is all, of course, cached and optimized in the webhook. But then you can, mutate, verify, validate, or generate resources. And the verify images, it's interesting because it has to run as a mutate as part of the mutate webhook, because it's not just about verifying the signatures, but also then replacing the tag with the digest, which happens in the mutate webhook, and then you can further validate, etc. Um, so yeah, on the right is a simple policy. It's just checking for labels, and it's fairly straightforward to read. Like the pattern is just an overlay, much like customize. So it will check for metadata and apply labels that supports wildcards and so on, right? Um, so before going to the cosine specific features, just I think some of the things we were talking about is between what does it take to, obviously writing a webhook is not difficult, but then to get to a production admission controller, bunch of features that have been developed, I guess, just in the last year or so in Kyverno. everything from high availability to observability with metrics and Prometheus reporting. Kyverno natively supports the policy report from the workbook policy, which means that you can use standard tools again to get policy reporting, and it's both namespace level as well as cluster level. Kyverno also puts data out in events. There's automated certificate management. One important feature which took us and it's still sort of being tuned and evolved, but it's important to get right is managing the failure modes. So we've moved to a very fine-grained model per policy, and Kyverno automatically manages all the webhooks underneath based on policy settings and what you've configured in your cluster. And of course, you can override and control this through various tunables, but for the most, it's just self-tuning and automated. Kyverno also automatically generates rules for pod controllers, so it recognizes pods versus pod controllers. Again, can be tuned and as you wish, but by default, it will apply policies at the controller level, even if you write rules at the pod level, right? So just to make things easy. And then data lookups from API server config maps. Kyverno is not intended. We don't envision supporting a feature to just call any arbitrary API or endpoint, but it does, support calling out to config maps, or it in fact caches and optimizes that, or you can call the API server for any lookup. So you would kind of, it's almost like you would flip the paradigm around. So if you want to bring external data, more external data from outside the cluster, you would have a separate controller that populates config maps, and Kyverno can then, you can use those in policies. It also natively supports JamesPath lookups. So, JamesPath is used in a lot of CLIs, but it seemed like a natural fit for doing expressions, and we'll see some of that even with cosine, etc. Right? So simple policy, and we'll kind of show a quick demo of this just to verify images. So just kind of reading the policy from like line 6, we're saying enforce instead of audit. We don't want this to run in the background, so it's webhook only. It's matching on line 13 a pod, but it will automatically apply to deployments and other pod controllers. It verifies images based on this pattern on line 15. And we're just checking to make sure all images are assigned with this one public key. It supports multiple keys. It supports also, like I mentioned, it will automatically mutate with the digest. You can configure private registries. There's also support for an optional signature registry. So if you don't want to look up the registry from the image reference itself. Um, for external data, this is just an example. I think Michael mentioned this last time, that one of the requirements he was looking at as using different tools and controllers is just the ability to fetch. And with Kyverno, you can kind of intermingle other variables. So you can build your keys based on image names, things like that, right? Which gives a lot of flexibility. If there's support for keyless. So this is just an example. This is a PR which is in fact just going into a support issuer, which was a newer feature as well as subject. And you can optionally specify routes, or you can configure like for the default route if needed, right? So that's for the keyless. Another feature that is available is to verify in toto attestations. So this allows any custom predicate type, which is quite powerful. So now you can match any type and then have various conditions. These are JamesPath expressions, and then there's operators and JamesPath functions which you can use to do more complex logic, right? So here we're just checking like reviewers. This is an example of how to kind of do something if you have a vulnerability scan report in a attestation. There's some work going on to do this for SBOMs as well, and validate various things in SBOMs. But some of this can get a little bit complex, but the idea is to make it as declarative and as simple as possible in the policy. So just in terms of where we are and what we're doing, so we're all of these features are available, like what I just showed, to test and use in the 1.6, which is our mainline main branch. The plan is to 1.6 is planned for GA in around end of January, And the things we're looking at adding in is SBOM verification, either through this style of verification, or we are kind of looking at whether there's some higher level support required with some common sort of commonality across SBOM formats. So those are things in progress. And then, so there's a number of like minor issues and stuff which I've linked here. Other things we're kind of discussing is whether we do native support for in-toto layouts, also for YAML signing verification. There's plans to put that in there. So that's a quick overview. I don't know how we're doing on time, but if we do have a couple of minutes, I'll show a quick demo.
Go for it.
All right. Any questions while I bring that up, or maybe we can do questions later. All right, so I don't have any cluster policies defined over here. What I'm going to do is I'm just going to configure, so CPOL is short form for cluster policies. I'm going to configure a policy just to check image signatures, right? And let me show you, I think I have that up here. So that's this policy, it just checks for a single signature. And what we'll do is I'll now, just try to run my image, which I don't believe has any signatures, but let me check while that's go here. Oops, spelled that right.
So GHCR added a feature where you can drop the image URL into your browser, and it'll pull it up, which is
oh cool.
Oh, nice.
I missed that from GCR, so I was poking their PM to add it.
Okay, so it failed the signature. So now let's kind of sign it with cosign and see if everything works correctly. We are looking at so once the image signature is up there in the repo, let's double check. We should be able to at least apply that simple image, right? So this is just signing and now running that one image. Oops, so it's already running. So let's delete it and try it again. So that should go through now because that pod exists. So the next thing I'll just do just to kind of show that that works as expected, right, is we can look, we can apply one of these policies, which is just an attestation for a code review, right, which is saying that I'm expecting this review to be done on main, you're my reviewers, etc. And if I look here, I have some JSON, which we will sign with cosign. So what are we doing here? We're saying, yeah, the type I'm passing in as code review v2, and we're adding that attestation. So actually, let's apply the policy first and see if it should fail, right? So we'll do check review. And if we run the pod again, now it should say that that attestation is not found and it fails, right? Which is what we're expecting. So now if we go ahead and do the cosign attest with the key, with that predicate and the type v2, we should see the attestation show up. Let's make sure of that. There it is. And now if we apply that, and I just want to make sure that I have the settings right. So yeah, it's type v2. We have Bob, who was the reviewer here. So we should be able to now run and pass that image, right? So that's a pretty straightforward demo where we're just checking for both signatures and attestations. So yeah, I mean, that's basically what I wanted to show, but yeah, happy to dive in more or answer questions if we have time, or we can do it after the other demos.
I have a question. I think you briefly mentioned it. Is it possible to extend or call any other APIs for these kind of new policies that you introduce, where we can find samples, if so?
Yeah, so Kyverno doesn't allow just calling external APIs from policies, but I mean, obviously, internally we are supporting calling out to OCI registries, things like that. But just for security reasons, the approach we took is we're not allowing policies to call out to any API endpoint. So, however, the easy way to kind of and the pattern we instead, advocate is write a controller which puts data in a config map, and Kyverno can read config maps, right? So it's just kind of inverting that paradigm where you're writing focus controllers on what you want to do. Which, like, what type of endpoints were you thinking of calling, or?
Was basically to see if it was possible, such as you can do with Gatekeeper, right? Like to define a specific
Mhm.
plugins for a specific
Yeah,
type of artifacts. So
right.
that was what I was having in mind. Um, yeah, that was one question. The other question I have, it's you define the policies. I was wondering if you really need to kind of add certain improvements, or kind of I don't know. For instance, one of the things that you might encounter is the scalability and performance, right?
Mhm.
If you need to improve those, do you have to change the source code of Kyverno, or you have another way to kind of improve certain patterns or certain queries?
Right. Yeah, it depends, right? So it really depends on what type of, if you're talking about just webhook performance, and most of the issues that we've seen is in how well you can register, and configuring or making the webhook configuration as fine-grained as possible, right? So if Kyverno, initially we started with the fairly naive approach where we said, okay, let's just receive every admission request and then decide whether we process it or drop it. But that quickly ran into scalability issues. So now we've moved almost to the other extreme where everything is very fine grained and controlled. So based on the policy set you configure, Kyverno is only receiving admission requests. So it will automatically redo the webhooks to only webhook configurations to only receive requests for the right, like kinds and versions, as well as namespaces and things like that. So yeah, so but and going back, by the way, to your previous question on extensibility, so we're very open to figuring out a more extensible model. The interesting thing to what we're wondering is this, it's nice to have plugins, but should those be runtime plugins? Should they be compile time? Should we support something like WASM? And I don't know the right answer, but it's a very interesting topic with webhooks in general, because you have 30 seconds to handle the request, and calling external systems is somewhat of an anti-pattern within admission controls. So you want to keep things as contained. In fact, there's a threat model that SIG Security has developed, and one of the things they recommend is keep webhooks within each cluster and don't call out to external systems within admission controls, right? So there's two different mindsets. We like the flexibility, but then it introduces some challenges for security and scale and things like that.
So I had one question, Shin. So this check review use case that you showed, that's really interesting. So the idea is when you get a Git event, you will basically attesting that Git event in the CI pipeline to the final product.
So the idea would be in your CI pipeline, you can attest using Cosigned. You can attach attestations, sign and attach attestations for anything you wish, right? Any event, any data. But then you can verify those in during admission control or at runtime in your cluster using Kyverno.
Okay.
Yeah, no, we're Matt. Yeah, saw your notes. So yeah, we can move on, and happy to. We can come back if there's time, or we can set up more sessions if there's other. Or I'm available, of course, on Slack. We can talk more.
Yeah, thanks. That was an awesome demo and slides. So thanks for sharing.
Sure.
All right. Yeah, I'll demo, and I think it actually suits it very well. It fits very well after the what you showed off there, Jim, because I will actually show the pretty much what you were just talking about. Let me see. Can I share multiple windows here? This and this? No, it looks like it only lets me share my entire screen. Okay, so I'm going to share my entire screen here. Or actually, you know what? Let me just share one thing first, and then all right. Okay, you can all see my screen, right? Do I need to make anything larger for anybody? All right, cool. Okay, so let me just run a build here. Second, so so this is the Secure Software Factory. For those of you who have seen some of the demos we had given at Supply Chain Con or at similar places, this may seem familiar to you, but those who haven't, the basic idea is we're building out a set of integrations between various open source tools like Tecton, Spire, Kyverno, and other things in order to sort of create a CI pipe, like a CI/CD pipeline that is secure and will generate artifacts that we believe, we can sort of attest their provenance. And then as time goes on and we introduce new checks and new things into it, we can, attest to different elements of how secure it is and those sorts of things. So just because it takes a couple of minutes, I'm going to run this pipeline while I kind of talk through what's actually going on here. So the configuration here, it's just a relatively basic Tecton task. It's all written right now in Qlang, which is it's just a data management language. But the basic idea is it does look, like normal sort of Tecton task. It's going through, it's doing a bunch of stuff here. While it's going through these things, we have Kyverno policies attesting that we're only using signed versions of builder images so that we're secure against that. So that if somebody comes in and replaces a particular task or parent image that isn't signed, it would, or it's not signed by a key that we trust, it would block it. And those sorts of things. And it will go through and will also attest to, it uses Tecton chains to actually attest to what's going on in the builds. It generates an SBOM. Right now, it's a relatively trivial SBOM, but it generates an SBOM, signs the SBOM, uploads it into OCI as well. And then finally, once it's finished here, we have a Kyverno policy that validates that it has right now chains provenance. We're going to be switching over to Salsa provenance shortly, but it'll check that it actually has signed chains provenance with the right key, and so on. And otherwise, you will not be able to run it in production. Okay, so let me just share 1 second here. Let me share the Tecton dashboard here. So it completed, and just to kind of show you what that looks like and what it did, right, so it created an SBOM for this project. It's just a very simple Hello World Rust project. It built the image, pushed it out to a registry, attached and signed the SBOM using Cosign. And using chains will automatically attest to what it did and sign that and push it out as well. And so that's what, so if I just take this here, copy that, and now stop present, whoops. And if I present again the window here, we can go and start to figure out, start to do some queries and start to run a few things, right? So one thing I can do, right, is I can cosign verify, I can do all that sort of stuff. A lot of folks have already seen that, and I don't want to take up too much time sort of rehashing that sort of stuff. But what I can show off is, so if I just do like a crane ls on right, you can see here in the registry, I have a bunch of stuff in here. If I go and look at what the digest was, right, it's going to be 7A, yada, yada. So I see that there is a signature. I see that there is a signed SBOM, and I see that there is a an attestation associated with it, right? And I can confirm those things and yada, yada. But let me just show you how some of this sort of stuff works. So right now I have a production namespace that I'm going to try and run something that doesn't have an attestation associated with it. So run, let me just do nginx, right? Nginx, and let me put this in, the theoretical prod namespace. Okay, it goes in and says, nope, I don't have a thing that matches, the signatures for an attestation. I don't have, I don't see a valid attestation that, is attesting to Salsa. Okay, cool. So, but if I go and I run the, oops.
Michael, we are not seeing your command. We are seeing VS Code. Is that okay? Still?
Oh, is it not showing up at the bottom there?
It's at the bottom of the VS Code window.
Yeah, let me try and make it a little larger here. Right, and for the sake of, to just show you, let me go and it's like this. Oh, whoops. Am I blanking on? It's going to be.
You have a .at the end too.
Oh, right. Yeah. What?
And you meant.
You know what? Let me just do latest for now. Sorry, I'm blanking on. So if I just do this, whoops, is it? Okay, hold on. kubectl run demo. Anyway, yeah. Oh, signature mismatch. I might have messed something. Oh, messed something up there. Oh, that's because I'm running in the wrong namespace, and so it won't let me run it in the pipeline namespace. It will let me run it inside of the prod namespace because the policy is there. Sorry about that. And so anyway, so this is the pretty much the demo I just wanted to show off. Obviously, as time goes on, we're going to be adding a lot of additional features into it and a lot of additional stuff and integrations. With the idea here being that we want to build out a CI/CD pipeline system that will only run things, will only build things that are abide by your policy, that are signed with the keys that you trust, that even dependencies need to be signed with the keys that you trust or have the certain attestations. And then when you move to something like production, the only things that will be allowed to run are the things with valid attestations that similar to sort of like a binary authorization sort of setup. That's my demo. Any questions?
So Michael, each namespace had its own signatures. Is that why you weren't able to run it in the
Yep.
other namespace?
Yep,
Okay.
correct. So in this particular case, it's not that it was in this particular case, the thing that we were validating was we were actually only trusting certain Tecton images inside of there, as well as certain Sigstore images inside of the there. And if somebody comes in with something else, right, like, hey, yes, this is a signed image, but it's not signed as a valid builder image, then we wouldn't trust it. As well, at least to run in that namespace, right? Because we don't want just random stuff running inside the pipeline namespace.
Got it. Cool.
Cool. Any other questions? Otherwise, I can hand it off to the next folks. All right. Cool.
All right.
Um,
So, Kavitha, are you going to present this?
Yeah, I'm going to talk about the pull request we made in Cosigned 1064. So this just talks about the change that we added in where you add a cluster image policy. It's just very similar to what Kaiwan was also doing. So this will look at all the pods that are coming in, or all the resources that Cosigned already looks at. They will look at the image pattern. It will see if it matches the pattern that is present in the policy and try to verify it against the keys that are specified for the pattern. So let me share my screen. Wait, I have not allowed Chrome to show this, so I might need to.
Those damn security controls always getting in the way.
Policies, yeah.
I might have to dismiss and rejoin. Oh God. Can I log off and rejoin again? Is it fine?
Yeah.
Yeah.
Literally every one of us has had to do this during a meeting. Promise.
Demo gods.
Yeah.
I'll be back.
I was doing a demo a few days ago where I didn't realize my Zoom had suddenly crashed. So I was talking for a good 5 minutes or so, and then there was no Zoom controls, and I had to log back in, and they're like, okay, yeah, they had moved on, of course, to the next topic, which was good, and I had to kind of redo that piece.
Wait, is Hector saying something?
Hector, if you're talking to us, you're muted.
Yeah.
Yeah, the same thing, Jim, but only with the mute button. So yeah, I was wondering whether, for instance, for the signing, it's kind of a standard, right? But for the SBOM files, what we encounter is a different type of formats, the different type of standards that are being used in order to enforce any in order to make any policy enforcement. So I was wondering whether you were assuming to just use a specific type or kind of do conversions, or yeah, that was my question regarding to SBOM mainly. Yeah.
This is for the Caverna stuff.
Yeah. Sorry. Yeah.
Yeah, so right now what we were thinking is, just verifying based on in toto attestations. So the idea would be we would support any custom predicate, and as long as that predicate can be rendered back as JSON, then using JamesPath, we would allow users to cherry pick, like various attributes in there and verify them as needed. So yeah, one of the things that I was working with a few other folks to try and do is to come up with a reference example of that and see if we need anything else in terms of a standard format, or just is raw James path, intuitive enough to allow that. Yeah, I'll send you a link. There's a PR and there's a good discussion, and we started a quick design document on that topic itself. I'll share a link.
So the
Awesome. Thanks. Oh, yeah. Go ahead, Matt.
well, it looks like our demo's ready. So I'm gonna
Yes.
hold that question and hand it over
I'm
to.
ready now. Demo gods have finally agreed with me. The change here that we made to Cosigned was to add the cluster image policy, where you would specify a pattern that would be run against the image that is present in a container. And you would say, hey, what key I want to verify it with. And then you can have a list of keys specified and then reference any of those keys here. And we the current implementation that we have put in this pull request does not do anything with this exclude namespace stuff, because we're still going out with what Cosigned already does, like labeling a namespace to be included for verification or not, because I think that was still a discussion that is still up and running, so we didn't want to do any of that. So right now the default setting is, if an image that comes in that does not match the pattern, it would be rejected. So I have 3 demo images set up that would, let me open my Docker Hub. Yeah. So I have 3 test Nginx images. One is signed. It has a signature. And oops, 2 images that are not signed, one that would match the pattern and one that would not match the pattern. So I have the webhook up and running, and I also have the cluster image policy. Match, see, demo. And this says that it will match this pattern. I have a test namespace, kubectl get namespace, test namespace. This has the label that Cosigned is looking for. And if I tried creating kubectl run test pod, yeah, the test pod now would be created. And if I use the unsigned, so it now fails, saying it matched the pattern. It tried to verify the signature. There was no signature present. Now it fails. And then I'll have another one, which I thought it was unmatched, I think. Yeah, unmatched. Unmatched Nginx. Yeah, so it tried to run through the policy, tried to verify the pattern, and it didn't match any pattern. And the default setup is, or if it doesn't match the pattern, you blanket deny it coming in. So this is what we have as the current implementation in the pull request. So which is just like basically whatever just Cosigned does, but with a pattern thing, which like includes what has to be gone through the verification. I think that's all I had. All the
Now,
hubbub I did
Tabitha,
for this.
now, Tabitha, we can take multiple keys. That's correct.
Yes, we can. So yeah, we didn't change whatever Cosigned was already doing. So if you list multiple keys, it would take all the list of the keys and it will do an OR for now, which is also another discussion that's up in the pull request. So if I can open the pull request and the accompanying issue that we raised. So what we didn't implement that is the unmatched image policy, which would probably tell you, hey, what do you want to do if an image does not match the pattern? So right now it's just built in the code saying it would be blanket rejected. So that is not there. And we also wanted to discuss about the and or policy and the threshold for the amount of keys that you need to verify if multiple keys are provided. So all of those are still like up for discussion. So we wanted to get in a basic implementation that can start a discussion further. Any questions?
No, looks good, but I think that does open up some of the stuff that I know we wanted to discuss, which is like how much of this should be, let's say, in cosign and cosign directly versus how much of that should be, let's say, if we were to say, like, whatever cosigned is doing is essentially integrated into something like Kyverno and other admission controllers.
Are you talking about the SDK discussion then at this point?
Yeah. It was more of just like trying to think, how much of this functionality should be baked directly into what cosign is doing versus, what because correct me if I'm wrong, but is it set in stone that cosigned itself is going to be its own full-fledged admission controller? Or is it mostly still supposed to be like, hey, here's an example admission controller, but if you need something a little bit more powerful that supports other use cases, you should be looking at other admission controllers? I have no idea.
I definitely think it should be fully featured enough to act as a good reference. If that makes sense. We don't need to support every use case under the sun, but we do need to support like some critical journeys.
Yeah, so I think my 2 cents is it should be a good reference cosigned admission controller, and sort of within the scope of what you can do with, say, cosigned verify attestation kinds of things. It should support sort of the capabilities there, but like admission control and policy kinds of things that extend beyond what you would do through cosigned verify star. I don't think it should venture outside of that, but cosign as sort of an SDK for these kinds of things, right, should totally enable other much richer admission controllers to do this, right? Like, as well.
Well, I think as you start talking about cosign as an SDK, the admission controller becomes an expression of that SDK, as does Kyverno's implementation of cosigned validation as an expression of SDK. And I think too that there's something that when we talk about cosigned as a full-fledged image signing validation admission controller, there are more paths forward than this does one thing, but go to OPA or go to Kyverno that does everything, right? We work closely with the Carvel team, whose philosophy on the front page is small tools, right? So there's a path forward that says that I have my admission controller that does exactly this validation. I have my attestation controller maybe that does exactly this validation, and that is certainly a use case that perhaps Tanzu itself would support, but I think something we would acknowledge. So if we could have, this is just my opinion after the last couple of weeks conversation, if we could have a future where we have a fully fledged, trusted, cosigned as we know it, that fits the use cases that we're describing here, that is, that we can say meets some SALSA specification. Not only is it a worthy reference implementation, but for those who are taking on signing and validation, can choose to use it and feel good about it. Does that sound fair?
And there's certainly some interesting trade-offs, right? And I think there's a lot of validity in having a good reference implementation. One thing, like maybe it may be interesting to draw some layers and kind of understand what we want to put where. So certainly a big motivation for this discussion was if we are building an SDK, then that allows others to sort of build on top, which is great, and add that flexibility. Totally agree that it makes sense to have a reference admission controller which showcases all of the cosigned features. The question is that something from the Sigstore project, whether the intention is to make that a production ready admission controller, because there's a lot more that goes into getting to that next level. Or are we saying this is a reference design and then go pick your production admission controller, which may implement that or add the other features, right? And here I'm thinking about HA and security, and there's so many other things that have to be done, right?
Yeah, couldn't those be like a add-on or on top of the functionality?
Absolutely.
Like, yeah, that could,
Yeah.
the functionality could exist as a
Absolutely. Yeah.
whole in Cosigned as a reference architecture or even an SDK or however we're talking about it. But then all those extra features we are talking about could wrap around it. So it is still valuable to discuss this piece.
Yep. Yeah, and it's a good proof point of any SDK, right? That we can use it and as a standalone tool, right? So, yeah, absolutely.
Yeah, when discussed with Dan the first time, it was integrated into the Cosigned repository. The idea was to have a single purpose admission controller, right? It was mainly focused on Cosigned, and whenever you need to new features of Cosigned, you are not breaking other external implementations, or everyone can benefit of that. So the idea of keeping an SDK is perfectly aligned, I think, with what everyone is doing, and I think is great. We would like probably to still contribute into to the Cosigned admission controller in order to have it with those features, and also being able to be a production ready, or at least stable enough. Then everyone can use a general purpose tools such as Gatekeeper, Kyverno. That is depending of what the use cases of the customers, right?
So yeah, to sort of echo that and to offer an analogy, right? I think that as a reference implementation, right, we don't want to build a toy, right? It should be something that folks can use in production. But if their production needs extend beyond the scope of what it's intended to do, right, they should reach for another tool. And I think that's totally fine. The analogy I'd make is, if you look at Kubernetes upstream, right, like they have ingress abstraction, right? And they have a few reference implementations like the Nginx ingress, and I think another cloud vendor integration. I think it's GCP, which are sort of upstream references for how folks do that, right? But there is a very rich ecosystem with many, many, many different implementations of ingress, and soon gateway APIs that have sort of come out of that, right? And I don't even know that Nginx is the most widely used anymore, but it exists to serve a purpose to sort of, it's not changing that much anymore, but sort of help shape and be a sort of reference that folks can use to see some basics. Imperfect analogy, because we won't necessarily all have the same APIs for some of this stuff, but I think
you definitely don't want to set up Istio for like Hello World.
Yeah,
sure, but if
Wait, I wasn't supposed to do that.
Yeah, so something you should start with. What is this?
Yeah. So anyway, so I think that we would be doing a disservice to sort of the ecosystem to put as a reference out there a toy, but I certainly do not think that it should we should scope creep or go beyond sort of the scope of what projecting the capabilities of sort of cosigned verification. Because there's a lot of great tools that do more than that, right?
Do you think like feature parity between like cosigned verify and cosigned would be like a good baseline goal. Like,
yeah, so I sort of said, I mean, this is my 2 cents, right? But this is sort of why I point to the sort of cosigned as an SDK sort of thing as, you know, what I see as sort of a guiding light here, right? So I think in the perfect world, Cosigned's a pretty good SDK for folks to build these kinds of things. And if we can get to the point where the CLI is really just an orchestration of those libraries in a certain way based on the flags you pass or whatever, and you know, the admission controller can be another sort of projection of that that's configured by some of the API we're talking about. The thinner those can be as clients of this SDK, the better. And I think the more we enable folks like, you know, Caverno and the OKA Gatekeeper folks to take that and integrate it with other things that they are able to do, and you know,
there's a tremendous amount of trust in that, right? That you know that you can go from the command line to the included implementation to Caverno to OPA to what have you, and trust Sigstore more for being able to move from one to another with absolutely no doubt. You know, that's a powerful expression of an SDK and a security tool where trust is paramount.
Right. Yeah, that makes complete sense. And I think one analogy that just keeps coming to mind is what SigAuth did with pod security admission, right? Because it went from internal implementation to pod security standards as a spec to a library. And in fact, in Caverno, we're now going to kind of, you know, use that library, right? So it's very similar, where it makes sense to have, you know, something which can be leveraged and can be natively adopted with that trust in mind, like you're mentioning, Adam.
So we have 4 minutes left, and I've got a hard stop at 9, but I don't know that we have time to fully launch into the sort of, you know, enumerating all of the solution requirements, even though we've sort of been discussing some of it. Do we want to jump into that on Monday in earnest?
Yeah, sounds good.
All right. Thanks for all the demos. This is awesome. And I'll try and get the recording up as quickly as I can, but I've got a few more meetings after this, and it has to like transcode and stuff. And then I have to find someone who has YouTube access. So thanks, everyone, and have a great weekend.
All right.
Okay.
Have a
Thank
good
you.
weekend.
You
too.
too. Bye.
Bye.